Square root functions, got to know how to graph them. If you know how to graph a square root function, you can graph any function that has a particular form. So this is why we focus on square roots this semester, but know that if you move into more advanced mathematics, you understand that function transformations, when you have a number attached to an x, kind of like it's in parentheses there, okay? Here it's a left and right motion, okay? And then if it's outside of those parentheses, then it's a up or down motion, okay? And then what you have to do is understand that the basic parent has a relationship with the data, okay? So that when you move over 1, you go up 1. When you move over 4, you go up 2, okay? So it's basically a quadratic that's been flipped, turned on its side, okay? Now this general shape then is going to just be recreated every single time, except for these two, because you got a 2 in the front. That's different. We'll address that. But right here, we're going to take this basic formation and we're going to move it to the left 5 and then down 3. So left 5 and then down 3. Now what we do is we're basically saying that the parent function always starts at 0, 0, but he's moving to the left 5 down 3 so that the entire thing rigidly shifts those units. So now we just recreate the pattern, okay? And then if I wanted to go up 3, then I would have to go over 9 because the square root of 9 is 3. So it would be 5, go to 4, and then 4 would be right here, okay? So there she is. All right. We'll actually do 44 after we do this guy. This guy is the parent function that has just dropped 2, not to the right 2, but drop because it's outside of those parentheses. So it would just drop, okay? And then we go up 1 over 1, and then up 2 over 4. Okay. The next one is going to be off of our graph. Those are the things we can do mentally, because the square root of square root of 9 is 3. So the square root of 6 is going to be like 2 point something, and we just kind of continue that that general shape. All right. Now when you got a parameter of 2, though, this is it's a multiplier. All right. So what happens then is our general parent function. Now, all of the outputs will get doubled as they come out. So if I were to double 0, well, doubling nothing just gives you nothing. Now, normally, when I move over 1, I'd go up 1, but my output is now doubled. So I'm going to double 1, so that would be an output of 2. If I moved over 4, it should be 2, but because I've got the multiplier of 2, that distance is now going to double. And then the next one would be 9, radical 3. We double that to 6, but that's going to take us off the charts. So we're going to just draw that, okay? Now we're going to take that basic shape here, and we're just going to drop him 3, okay? So it's still a multiplier of 2. So we're going to drop him to 3 here. No right or left movement, because there's nothing on the inside of the square root. And then we're going to go over 1, but we're going to double the output. Move over 4, but we're going to double the output. Let me be careful here. 1, 2, 3, 4. Okay? But you should always get some kind of hook shape when you are graphing square roots. Okay? All right. Totally different topic. All right. Now, what I'll do is, just to kind of save us some time, is I'll just set up the problem. And when I set it up, just, calculator, and you can punch it. Okay? Nah, you know what? I should write down the answer. Okay. So actually, what I'll do is this. I won't even write it down. What I'll do is I will just punch it into the calculator as I see fit. Okay. We got a savings account is compounded continuously. Okay. So that is that's the PERT formula. Okay, because it says continuously. If the interest rate is 4%, that's the R, okay, and the current balance is $1,250, okay, what will the balance be 6 years? All right, so we got all the required pieces of information. There's our P, that guy right there is our R, and then we got 6 years for the T. So we're going to plug it in as we see it, but remember that 4% is 0.04. So if we just took 1250 and then we get our e to the x button, which is right here, e to the x. It'll put our e in there, and then we will also get the superscript so that we can go 0.04 times 6 years. Push over so we can close those parentheses, but you don't even really have to do the parentheses. It's not required. You can just put multiply. And we've got 1,589.06. That's how much the balance would be, and that makes sense. Okay, it's in there for 6 years. You're only getting 4%. Okay, so that checks out. This is also compounded continuously, but it says that the balance doubles every 23 years. Okay, so it doubles every 20 in the current balance. What will the balance be 6 years from now? Okay. So it doubles. So this means we don't know the interest rate. Okay. So every 23 years it doubles. Okay, this I'm thinking of the rule of 72. So I have to get away from that for a second so that I can explain this a little better, because this might be outside of our purview here. Is there anything that we can do that you guys know from what I've taught so far, or am I going to have to get pre-calc on you? Let's see, if it doubles every 23 years rate. Okay, so the rule of 72, if I took 72 and divided it by 23, that usually gives you the interest rate. But I didn't teach you guys the rule of 72. So 48, we're going to have to skip that. All right, so if you didn't get it, that's okay, because this doubling thing makes it a little bit more complicated. It's not much. In fact, it would take about 10 minutes for me to explain it, but it's better in a pre-calc class. That's why I didn't actually teach you guys that. So we're going to skip 48. Okay. All right, let's see if this had, see, 49 is the same thing. Yeah, this is a rule of 72 problem as well. So there you go. There's 2 less problems you have to do. If you've gotten this far, you probably got those wrong. You know, the rule of 72 says that if you took the 72 and divided it by the number of years, you'd actually get the rate, and then you would use the rate for that. But, you know, whatever. It's okay. We're not going to do the rule of 72. That's new information. All right, well, let's see if we can do this. A place outside, temperature is 0. Assume the coffee cools to approach the outside temperature according to an experiment. The continuous cooling is determined to be 3% per minute, and the current temperature is. Okay, so looks like we have a continuous rate of change. All right, which is obvious, right? Temperature cooling. It doesn't just click, you know, each minute to a certain point. It's always continuous, right? So it looks like, all right, so it's colder outside, and it's going to approach 0 degrees, but it's going to drop 3% every minute, and it started at here. So as it's going towards 0, what is it going to be 9 minutes from that? So we have the amount. We don't know. Well, the amount is the temperature, but we started with 59.6 degrees. Okay, we are now going to drop by 3% every minute, and we're going to be out there for 9 minutes. Okay, so let's see what we've got here. 59.6 e to the negative 0.03. Now, obviously, it's very important that you knew that the temperature was decreasing, so that's why the rate is negative. Okay, and then let's see, does that make sense? Is it reasonable to say that after 9 minutes, the temperature of the coffee is 45.5 degrees? Yeah, I think so, right? Because, yeah, it almost dropped 15 degrees in 9 minutes. Yeah, that's reasonable. I think coffee would probably get colder than that, but it depends on what kind of thermos it's in, right? All right. Okay, 51. Ariane invests 5,000. I know a guy named Ariane. $5,650 in the savings account with fixed annual interest rate of 7 compounded 6 times per year. What will the account balance be in 7 years? Okay, so this is compounded, and if it's 6 times, that means it's bi-monthly. So this means the amount equals 5,655. All right, now this is compounding, so we need that formula. Some of you guys I don't know if you didn't write the formula on your note card or what, but you know, don't overthink this. Some of you, I would just write one example on your note card, and then that way you can look at, okay, that's how you do it. It's just a formula. I don't want you overthinking it. You do the same thing every time. The only thing that's really changing are just the numbers in those slots. Okay, so there's no great jump of mathematical know-how when you actually just follow formulas. Okay, formulas are formulas. It's nice to know where they come from sometimes, but if you don't want to push yourself to know, you can just use them. Okay, now I'm just going to type it in exactly as I see it. In fact, I'm going to put that fraction bar in there too. All right, and then we're going to go ahead and raise that to 6 times 7, because if it's been 7 years and they do it 6 times a year, it's going to get compounded exactly 42 times. So that's 9,200. All right, just want to make sure. I think annual is 7%. Yes, 7% is kind of high. So 9,000. I feel like that's still just a little. I'm going to double check this. 6 times per year, 7%. 7 years. Yeah, that's right. Okay. All right, so now we got invest that much in a retirement account with fixed annual interest, 8 compounded 12 times a year. So same thing. All right, same thing. In fact, I'm going to go straight to my calculator with this one. I'm going to have. Wait a minute. Let's push up there. Let's actually copy that. All right, and then I'm going to go right over this because this looks like we can. Kind of easy to do here. I'm going to keep the 1 plus because it's getting larger. We saw it was 8%, so let's put that 8. And it's compounded, how many? 12 times a year, so 12. All right, so 12. And then it's going to be in there for 18 years. All right, you should see a substantial amount of money there. $24,489. That is a very good investment. Okay. All right, what do we got here? Oh yeah, this stuff, it's all the same. You know, don't worry about it. 6 times a year, so it's going to be just like this. It's going to be 4%, so he'll go there. And how long will it? Oh, this is different. How long will it take? Okay, so here's where we need to use the tables. Now in pre-calc, I'm going to show you how to do this by hand, but in Algebra 2, I don't. Okay, we don't actually learn logs or logarithms. Okay, so here's what we got to do. We got to go to y equals. Okay, we got to shut off our plots in case anybody was graphing things. If you notice something's weird with your tables, just come and see me during your exam. Then what we got to do then is we have to say that we start with $3,558. Now it's going to go up by what was that? Okay, it's going to go by 4%. Oops, let's do the fraction bar. All right, DEL, DEL, DEL. Okay, 0.04. And we're going to do this 6 times a year. Okay, and then parentheses, raise it to the 6 times what? We don't know. So we put an X. We don't know when it's going to equal this number right here. Okay. Now what this allows us to do, okay, is if I do a zoom standard, now don't hit zoom standard, okay, this is a graph of what we just did, and it's going to tell us all the values, but clearly we are off the screen. We're dealing with thousands of dollars here, so it's not going to be in our home screen. So what we want to do is we want to look at the table, okay. Now where is the table? Second graph, all right. Now here, I started at 9, and it's because somebody was using this before me. So if I go to second table set, and you might want to write this down in your note card, I can control where I want to start and how high I go up. Now, since we're talking about years, why don't I just start out at year 0, okay? And I'll just go up by 1 year, okay? But I can go up by as many as I want. Now, I'm going to go back to the table, okay? And what I'm looking for is $5,974.34. So I'm going to scroll down here. Okay. All right. And it looks like they were looking out for me right there. They knew. Right there. You can see 34. So right there is where it equals T. Okay. This means it equaled that amount of money at 13 years. Okay. So it would be 13 years. We will equal that amount. Okay. So we got to use a table if you can't use logarithms, okay? So the same thing with here, except here we've got compounded with 8%, 6 years, different amount of money. When will it take for it to become that much? Okay, so let's go back to y equals. We're going to change our numbers here to 2,474. We're going to go to 8%. All right, and it's going to be 6 times a year. And so we'll leave that 6x right there at the top. Okay, we're good. So now what we'll do is we'll go back to second table set. We'll start at 0 again. Go back to second table. And we are looking for 7,500. Now we could just keep scrolling. It's not too bad. Oh, is that it? 7,526.5. If I click over there, there it is, 0.54. Perfect. That's 14 years. Okay. All right, so you're really just using technology to use the setup, right? You're using your mathematical know-how and technology to put these numbers together. Okay, whoa, 17 minutes. Holy smokes, that's a long video.